Good evening, everyone. A very warm welcome to all the students, educators, and astronomy enthusiasts joining us today. On behalf of Space India, I am delighted to welcome you all to this special session organized on the occasion of March Equinox 2026. My name is Rishita, and I will be your host and moderator for today's session. It is wonderful to see so many curious young minds and educators joining us from different schools. So, before we begin, I would like to share a beautiful thought by the renowned astronomer Carl Sagan, who once said, "We are a way for the universe to know itself." So, and moments like today truly remind us how connected we are to the cosmos. So, twice every year, our planet reaches a fascinating point in its journey around the sun, a moment when day and night becomes nearly equal across the entire Earth. The celestial phenomena is known as the equinox, and it beautifully reflects the cosmic balance that governs our universe. So today we gather to explore the science and significance behind this remarkable astronomical event. So today's session is titled as Cosmic Balance: Understanding the Science and Global Significance of the March Equinox. The equinox marks a unique moment in Earth's orbit when the sun is positioned directly above the equator, resulting in nearly equal durations of day and night across the globe. Beyond its scientific importance, this celestial event has also been observed and celebrated by civilization across the worlds of thousands of years. Through today's session, we will explore the astronomical science behind the equinox, the Earth and Sun relationship, axial tilt and motion, orbital motion, and how these cosmic mechanics influence the seasons and natural cycle on our planet. So, most importantly, today's session gives students the opportunity to interact directly with a distinguished scientist, making this both an engaging and insightful experience. So it is now my privilege to introduce our esteemed speaker for today's session, Professor Shantanu Rastogi. So Professor Shantanu Rastogi is currently the Pro Vice Chancellor of Deen Dayal Upadhyay Gorakhpur University, Uttar Pradesh, and has also served as a professor in the Department of Physics with more than 3 decades of experience in teaching, research, and academic leadership. He also had the privilege to be the Vice President of Astronomical Society of India during 2019 to 2022. He completed his postgraduate studies from IIT Kanpur and earned his PhD from the University of Lucknow. He has also been an Alexander von Humboldt Fellow in Germany, reflecting his strong international research engagement. Professor Rastogi's research lies at the intersection of astrophysics, atmospheric physics, and spectroscopy, with significant contribution in areas such as astrochemistry, interstellar molecules, aerosols, and infrared spectroscopy of polycrylic or aromatic hydrocarbons. His work has been published in several renowned international journals, including Astronomy, Astrophysics, Chemical Physics, and Advances in Space Research. And his research has also been highlighted in Nature India. So, in addition to his research contribution, he has been actively associated with leading institutions such as IUCAA Pune and PRL Ahmedabad, and has also been involved in science outreach initiatives, including solar eclipse observation and comet studies. So, we are truly honored to have such a distinguished guest with us today. So, without further delay, I would now like to invite Professor Shantanu Rastogi to share his insights on the science and significance of the March equinox. So, Professor Rastogi, the virtual stage is yours.
Thank you, Ishta. Thank you very much for a nice introduction. I welcome all the students in the world of science. Different events, celestial events, are important because they tell us about different questions that we all always have from our childhood. So today we are trying to celebrate, or in a way, we are trying to encourage you all to think about our universe as a whole by a small event, which is because of certain geometry of sun and earth, which is called equinox. And it occurs in March and in September. And then there are two other important events. I will come to those events shortly, but this is the first slide, which is also an event, which is a solar eclipse event. And it is also related to geometry of Earth, Moon, and Sun. So just for curious people, I have put this up to uh, I start with how the solar system formed and why are we having this unique geometry, because of which we have different seasons, and actually because of this we have life on Earth. So I move on to my next slide. So here in this slide, you can see that a huge amount of gas and dust somehow accumulates in space. Interstellar space is very, very vast. You cannot imagine, because we will talk about the size in terms of some units like light year, the amount of time light takes to travel, the amount of distance light takes to travel in 1 year, that is 1 light year. And so if we talk about 1,000 light years, it means that the space is covered by light in 1,000 years. So this is the almost the size of this sphere, about 1,000 light years or so. But because of some instability, the gas and dust starts to collapse. And as it collapses, there is some dense medium in the center, which attracts more mass, and the process continues. And this happens because of gravity. So it is the gravitational force attracts uh, each and every mass. The heavier mass seems to be attracting the smaller mass, like the Earth is attracting us and we are able to move on Earth. So here you can see through the arrows, they are all moving towards the center. And there is a arrow, yellow arrow, which is there in the center, which I have made to show a quantity. It is the axis of rotation of this whole huge gas and dust blob. It is important because it imparts, because everything that is moving will have some angular momentum, and this is actually representing the direction of angular momentum. It is a important quantity in physics. Uh, it is conserved unless there is some external force applied on it, and since there is no external uh, force or couple acting in space, it is only gravity, and that is the gravity of it itself. It starts rotating. As the whole mass starts to condense more and more, the space becomes smaller and smaller, and it gets heated up. And while this is happening, I'll show you through this diagram that there is, just a moment. Yes, here I'm showing this whole sphere with some forces that are acting on the mass at the edge. At the edge, there is, since the whole sphere is rotating, the mass is being acted upon by a centrifugal force, which is called Fc. Whenever you rotate in some swing or something, you feel a force which is trying to pull you outside uh, outside the rotating body, and this force is called centrifugal force. And there is, in addition, there is a gravitational force which is pulling it towards the center. So this mass is being exerted by two forces, and the resultant is a force which is downwards, flattening the whole mass, making it from a sphere, flattening it to a disk. And it forms a disk like you can see in the next slide. Sometimes the slide stops. Can you see the next slide, Rishita?
No, sir. We are still on the second slide, which is like the high amount of gas and dust in space starts
Yeah,
to collapse due to the self gravity. We are on that slide.
so it is not moving forward. Yes,
Yes,
now can you see the next
yes,
slide? Yes.
yes.
So uh, here you can see the sphere has now become a disk, and there are some masses shown with brown color which are more dense, and they start accumulating nearby mass while the central thing is attracting all the mass which is surrounding it. So this is what is happening. This is called a nebula, where a star is being formed along with a planetary system. The central region is very massive, and here fusion starts. A fusion reaction gives out large amount of energy. It gives, and we call that central point as a star because it is emitting energy out of fusion reaction. So a disk like this starts forming where planets form in the disk like in the brown blobs here. So this is how our solar system formed. And as you can see, the reason for showing you all this is that why all the planets are in the same plane. Because the initial nebula, which was spherical, due to some physics laws, some forces, it is now a disk. And this disk has planets in it. There is a central star and large amount of dust and some massive objects like asteroids. There are some comets which do not follow the law because they are very small, they can move in any direction. And these comets may be outside the plane, but all other planets which are massive are in this plane itself. You can see in the figure below, uh, the maximum angle deviation from the plane is 6.3 degree for Mercury, but all others are within this plane. So it is a very important phenomena that all the planets are in the same plane. So this is what happened to our sun about 4.6 billion years ago. That is the age of our solar system, and this is how the solar system formed. We have 8 planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. There are 4 which are called the inner planets. These planets are hard, rocky material, and they are probably attracted towards the sun more, so they came closer. And the outer planets, which are more massive than these, are gaseous planets. So, like Jupiter, Saturn, Uranus, and Neptune, these gaseous planets, and in between there are asteroids, which are not a spherical shape, but they are solid, hard stone of very variable shapes. There are dwarf planets like Pluto, which earlier we used to count among the planets, is now not called a planet but is called a dwarf planet because it has a moon which is almost the same size as itself. And there are certain nomenclature rules which are not followed by Pluto, so it is now among dwarf planets. And uh, the reason for putting Pluto in among dwarf planets is because after we about 25 years ago, there was discovery of several planets like Iris, which was very massive, Ceres, Make, Cubia, and these are some names depending on who discovered these, which country the scientist, astronomer belonged to. That kind of names are given to those objects. And because there were so many, uh, International Astronomical Union had to relook at the definition of planets, and they called some planets which followed certain rule. There are 8 planets, and others which are planet-like but not following all the rules. They are called dwarf planets. But there are other objects like interplanetary medium, comets, and asteroids which are there in our solar system. So from the large scale solar system, we are now moving more and more closer. So now let us come to the Sun Earth system. We have, uh, as we come closer, we have the Moon also along with Sun and Earth. And we can see in this figure, the Earth is moving around the Sun while the Moon is moving around the Earth along with the whole total movement is all three are mutually gravitationally bound. So 1 year is the complete revolution of the Earth, and Moon goes around the Earth in 29 days. So in these 29 days, sometimes Moon comes in between the Sun, and sometimes it is on the far side, and we see different phases of the Moon. When we Moon is not having its own energy. Only a star has its own energy, and it is only reflecting the light that is coming from the sun. So we can see the moon in different directions. Different parts of the moon will be illuminated by the sun, and we will see the phases of the moon. So in this figure, there is a very interesting question which comes to your mind that during a full moon, the earth is in between the sun and the moon. So there will be lunar eclipse. So every full moon should have a lunar eclipse, and every new moon should have a solar eclipse. But this does not happen because the moon is about 5 degrees inclined to the plane of Earth and Sun. So Earth Sun plane is uh, an ellipse or almost a circle, and Moon and Earth uh, is also a plane, but these two planes are inclined about 5 degrees. This is one reason why we uh, think that when the solar system formed, as I showed in the previous slides, Moon did not form. Moon formed much later. So Moon is not 4.6 billion old, it is less than that, but it also formed long, long ago. So because of this 5-degree inclination, only a few times when the alignment along the nodal line, the line which cuts the two planes, only then we see eclipse. We don't see eclipse in every full moon and every new moon because of this angle which is uh, not in the same line, which do not put the earth, moon and sun in the same line. So now we come to the point why we are here today. The earth's orbit around the sun is there, but the earth is also rotating about its own axis. The earth is rotating about its own axis, that is, in 24 hours, one rotation is completed. That is why we have a day repeating itself in 24 hours, 23 hours, 59.25 minutes to be exact. So, but this axis is inclined by 23.5 degrees. So because of this inclination, you can see that the northern pole is at some time inclined towards the sun, at other time after 6 months Okay.
Uh,
Yes. So,
Sorry for the inconvenience, everyone. The webinar is live back again. So, sir is sharing his presentation again, and we can continue. Thank you so much, sir. And thank you, everyone, for your patience. We are back live.
okay. Thank you very much. Sorry for the interruption. Uh, we are now talking about the inclination of the axis of rotation of Earth. This rotation leads to uh, the change day and night, and uh, the whole year, that is the revolution around this sun, is taking uh, is in a different plane. So there is inclination of 23.5 degrees, because of which for some period the northern hemisphere is inclined towards the sun, and that time northern hemisphere has summer, which we are approaching very fast, and uh, some period the southern hemisphere is inclined towards the sun, which is the summer in southern hemisphere. So it is a difference of 6 months. You can say half the orbit that changes. So what actually happens is, during different inclinations, you can see here in this figure, there is two equinoxes. One is March equinox and the other is September equinox. So this is because of this inclination, the sun is seen by each observer on the earth in a different direction every day. In the next slide, I will show how that difference comes about. But the important point is that between Tropic of Cancer and Tropic of Capricorn, which is 23.5 degrees north, which is Tropic of Cancer, and Tropic of Capricorn, which is 23.5 degrees in the southern hemisphere. So between these two ends, the sun is just overhead equator. It is crossing the equator, and this is the importance of the day tomorrow, which will be the March equinox. And in September, it will go be this is it is crossing from southern hemisphere to the northern hemisphere. Uh, During this crossing, we have March equinox. When it goes back, when winter is approaching, it is going back from northern hemisphere to southern hemisphere, which is September equinox. The maximum angle is either at the Tropic of Cancer or at the Tropic of Capricorn, and these 2 points are called solstices, because here what happens is, because the curve is almost a tangent, it remains, the sun remains overhead. It seems to be overhead for a few days, almost a week. So this happens in June and December. These are called solstices. And uh, during the equinox, the name equinox is because each point on Earth has equal days and equal nights. Night and day are equal because it is just above the equator. So what you can see here is, if from one particular place you observe the sunrise and track the path of the sun, each time, each day, it will be a different path. And it starts, if you look from winter, it will be very far, inclination is more. And as it comes to the equator, it is coming up. And when it is summer in June, it will be the maximum up for the northern hemisphere. And you can see the different curves. And if a time lapse photograph is taken, like in this picture here, there is an interesting photograph taken from an observatory. Uh, these are the whole year track of the sun. The lowest track is during winter. It is from the northern hemisphere. The lowest track is during winter, sunrise and sunset. And during summer, sunrise and sunset, it goes to at a different height. So because of this, another interesting phenomena happens. So this is a time-lapse photograph, which means uh, the camera was kept, shutter was kept on, and we could record the motion of the sun. So another thing that interesting phenomena that happens is zero shadow or smallest shadow day for all those people who are between Tropic of Cancer and Tropic of Capricorn. There are 2 days in which you can observe zero shadow day. So, and for those who are not within this region, they will have, they will never have zero shadow day because the sun will never be overhead. But they will have, uh, if you are close, like in this picture, I have shown our laboratory in Gorakhpur, which has 27 degrees latitude. It is about uh, 3.5 degrees above Tropic of Cancer. And we have placed different rings on this glass. There is a small ring, and then there is a tape which is like a cylinder, and then there is a big cylinder which is a shuttlecock box, and there is another box which is slightly. So we have four different lengths cylinder, and we can see four shadows here. Only in the shuttlecock box you can feel that it is not zero shadow. There is a slight shadow is extended in two directions a little bit because it is 27 degree north. And this photograph is on 21st June, which is the uh, day on which maximum reach in the northern hemisphere of the sun has occurred, which is the solstice, northern solstice. And but if you look at Bangalore, this is a photograph of Bangalore. You can see so many people here, and their shadow is negligible. This photograph is of 24th April of 2024, 2 years ago. Uh, the latitude is 13 degree north. So while crossing, coming up in the northern hemisphere at 13 degrees north, uh, the zero shadow day was there in Bangalore. The day will be again there on 18th August. So if you are aware, if you are somewhere between the uh, in the southern part of India below 23.5 degree latitude, you will be able to see this zero shadow day sometime or the other. You can consult your teachers or the internet to check for your particular latitude what will be the day for zero shadow. For example, here for Bangalore, these are the two dates, 24th April and 18th August. And for all others in the northern north of India, like Delhi, Gorakhpur, Lucknow, all these places, there will be only one day which will be smallest shadow, not a zero shadow. So these are some uh, good, interesting effects of geometry of the solar system, how the solar system formed, and how the inclination of different rotational axis is there. So one last thing, an interesting phenomena occurs because of the atmosphere on the Earth, because of the atmosphere has different refractive index. If you have studied the phenomena in light, so when the light goes through a medium, it if the medium is denser, the light bends towards the normal, it bends down, and there are different layers of the atmosphere. And as you come closer to the surface of the Earth, the density of the atmosphere increases, the refractive index increases. So because of this, even when the sun is below the horizon, the sunrise can be seen here because of the atmosphere, because of bending of light. This is just a few minutes difference. The apparent position will be above the horizon. So any person who is on this location will feel that sunrise has occurred, although the sun is still below horizon. The same thing will happen during sunset. And overall, because of this effect, the length of the day is longer than the length of night. is slightly longer of this, because of the presence of the atmosphere is bending light here. So I think I will now take up your questions if you have any, and I thank you all for your patience.
Thank you
If
so
you
much,
need
sir.
any clarification or if there are any questions, you are welcome.
Sure, sir. We do have a lot of questions. I will take those questions one by one. So, before that, thank you so much for that insightful and fascinating talk. I'm sure our students found it extremely interesting to learn about the science behind the equinox and the dynamics of Earth Sun relationship. You showed real time pictures as well. That was very thoughtful of you. So now we will move into the interactive Q&A session where students will have the opportunity to ask their questions. They have already fill those questions in a response sheet. Students, if you have still those questions and you have not filled in the response sheet is there in the comment section. You can fill that up one by one. I will start having the questions now. Okay, so let's begin. Hmm. Now we have an interesting question coming up from one of our students from Bal Bharati Public School, Sector 14, Rohini. Her name is Naisa Suri, and she is asking, how did ancient civilization observe and use equinoxes in their calendars and architects as an architecture?
Yes, that is a very good question. And uh, this science is different for different places. This observation will be different for different places. And in ancient civilizations, the places which were more developed, where there was peace, scientific curiosity took over. And when people were not always fighting and were not afraid of the surrounding, they started thinking of various aspects in the sky. And sunrise and sunset, these are things, and season was observed all the time. It is repeating. Summer comes, winter comes, and then summer again. So these observations were always there in their minds, and they started looking at different positions of stars as well as the sun at different times. And they came up with different concepts. And if you want to maximize sunlight, which direction you should be looking. For example, very crudely, we can say today, when we use solar panels for using solar energy, we try to put them in the direction of southeast. Because we are in the northern hemisphere, most of the time sun will be in the south direction. So it is put in the south, inclination is towards the south. But when you go to the southern hemisphere, if you are in South Africa or in Australia, then your concept will be different. You will be putting your solar panels in the northern direction. Uh, so for different latitudes, for different locations, uh, different civilizations made up according to their regional needs and other things. Like in India, we had our main source of economy was agriculture, and since ages, uh, people have decided which is the best season for which crop. So all this decision is based on observations and of the seasons and observation of different planetary objects. For example, different stars, faraway stars. So I think it would have taken years for them to come to this conclusion. We are being benefited by our uh, ancestors' knowledge to enhance more further knowledge.
So thank you so much, sir, for that wonderful explanation. I hope it answers her question. So moving on, we have another thoughtful question from a student. His name, the name is Siddhi Devedi, and the student is from Amity International School, Mayur Vihar. And the question is, if the sun is directly over the equator on the equinox, Why isn't the equinox the hottest day of the year for equatorial regions?
Uh, yes, though the temperature does not depend only on the position of the sun. Our atmosphere also plays an important role in it, and the circulation of air because of being heated up by the sun or other phenomena that are happening on the surface of the earth. So uh, it is hot when the sun is overhead, and thumb rule is that it will be the hottest for that particular region. So in general, you know that all the tropical region, that is all the geographical locations which lie between Tropic of Cancer and Tropic of Capricorn, they are called tropical regions. These are hot and humid regions. When you go to higher latitudes in the northern hemisphere, it is mostly cold. Like if you go to Europe, if you read about Europe, there's always cold. There's never summer. Even summer is also cold there. So when the latitude is higher, the inclination of the sun, even when it is at Tropic of Cancer, is still great. Suppose you are at 50-degree latitude, this would be, I think, somewhere in around London. The 23.5 degrees position of the sun is still 25 degrees inclination for uh, people in England. So it will be not a direct sunlight, it will be tangential, and that will not be very that will not be hot enough. So thumb rule is, you are right, is that when sun is overhead, it is should be hottest, but there are other factors which sometimes don't make it hottest, but it is still hot.
Okay, that was very insightful explanation, sir. We have a very relevant question related to today's topic from one of the students from Manavsthari School, Delhi. The name is KV Jyotsna, and the student is asking, what observational or experimental activities would you recommend for students to better understand equinox related concepts?
So I would like to make a comment. I'm happy to note that most of the questions are from girl students. It's a good thing. The important point is that uh, these phenomena, they make you interested in science, and then once you are interested in science, you start reading more, trying to understand more, and then your concepts on different aspects enhance. So it is good to take part, not only for yourself, for improvement of yourself, but also to encourage others. Like I said, Zero Shadow Day was one of the very interesting events, and everybody tries to see when the shadow is smallest, you are standing over your shadow. So that is something very interesting. So uh, that can happen only for people who are within the tropical region. For others, it will not be possible. Then you can see, uh, watch like this figure here. You can watch the position of the sun at different times. You can make a, say, if you are looking out of the same window every day, you can make a mark that there is a tree or something, your neighbor's house is there, and you can make a note where sun was at 12 noon, or take any other time, say, whenever you have time, say 5 o'clock. Uh, 5 would be, I think, very late in the evening, but for some during the winter, it might not be there. But you can try to observe different positions at different times in different months. If you make 12 points for each month, you will see, you can see how the sun has moved. You may not be able to take this time lapse picture, but but you can make a note every month, on a particular day, you make a note at 2 p.m. where is the sun from your window, and then you can check how it is moving throughout the year. So this will help you trying to explain the geometry, how the sun is overhead and how the tilt, what is the location in the Earth Sun orbit, what is the location of Earth at a particular time. So I think it is good uh, for understanding, and most importantly, it is encouraging you to study more. Once you start studying something, you would like to know more. Like today, I
Uh,
tried to tell you about a star formation from the beginning. Although we are still we are looking for equinox, but our understanding for eclipses and how the star forms, how the planets form, that also enhances. Yes.
Yes, thank you, sir, for sharing that. So, since you're from a teaching background, I found a very interesting question, which personally I would also like to have the answer for. So, this question comes from Harman Pal Singh, again from Amity International School, Mayur Vihar. So, the question is, how can equinox phenomena be effectively used as a pedagogical tool to enhance conceptual understanding in astronomy and physics education?
Yeah. So
Any?
the yes, your today's event is your answer.
Yes.
See, when you really see as a student, I think when you really see or do something, you learn more than when you just read in the book. So if there is a phenomena like equinox coming, then you make some observations. Uh, where is the sun? What is the length of my shadow, or what is the length of the shadow of the stick? How it is moving as the day is moving, and these kind of things you can do with your teacher, or as an excuse the equinox day will be there. You can do these experiments on any day, but equinox day or solstice day gives you an excuse to do these things. And when you do something in lab or in the open, when you make some observations yourself, when you get involved, then interest comes and understanding becomes faster. So I think that that way these events are taken up by teachers to inculcate this kind of interest among the students.
Yes,
All
sir.
day has something or the other for you.
Yes, of course,
Some
sir.
special days are an excuse for us.
Yes, of course. Again, it was a wonderful perspective of yours. Then we have one question from Ratyush Kumar Sahu. And the question is, why doesn't the equinox date remain perfectly constant every year? How does Earth's axial tilt and orbital motion together determine the exact timing of the equinoxes?
Yes, it's a complicated question, but I think scientific answer will be more complicated. I will just try to add the dynamics of sun and earth, or in fact all other planetary bodies, is a bit more complex than simply a tilt of 23.5 degrees. So our axis, if you look at the night sky, and if you try to trace where is the pole star, and if you connect the center of the earth with the pole star, that is the axis of rotation today, and maybe it was there for the last about 1,000 years. So this tilt keeps changing, but very, very slowly. So the date of equinox for our lifetime remains almost the same. Maybe one day it will be slightly shifted by one day, but not more than that. So during our lifetime, it will remain constant. So
Okay.
all the other dynamics that I just talked about, that the axis itself will be rotating, but is rotating very, very slowly. And once that, if the time elapses, say for example, I can tell you it is the period of the rotation of this 23.5 degree inclination is 26,000 years. So in 26,000 years, uh, the axis would have persisted around, uh, which will not be visible to us for, say, 100 years or 500 years, because that is a very long time. So once that time has elapsed, we will find a different position of North Star. We will find a different position for our inclination. And once the inclination with respect to the sun is different, the seasons will change, and the date of equinox will change. Everything will change. But that change is very, 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 very small, gradual. Within one lifetime, we will not be able to see that.
Okay. So, sir, we have few questions from the comment section. So I'll pick those questions one by one, and they are a little bit of a tricky questions. So I think they
My
are
questions
also
are
very
usually tricky. The
yes.
students have tricky questions.
Yes, and they are actually related to your background as well. So, like the first question is, how does the March equinox illustrate the fundamental principles of celestial mechanics, particularly in relation to Earth's axial tilt and orbital dynamics?
Yeah, I think we discussed that. So, if you study physics, you will try to understand why we have circular or elliptical orbits. Uh, these are some of the things that you will learn gradually. And during the equinox or during any other event, we understand it is a sort of proving whatever concepts of physics that we study. It is a proof. These observations are a proof of these uh, the concepts. So I think we have talked about the orbital dynamics and things, but you have to understand more about centrifugal force, about gravitational force, mainly gravitational force, and how different bodies get attracted towards each other. There is one by R square law, and there are Kepler's laws and all those things. When you study them, you will understand the dynamics much better.
Yes, sir. So,
Yes.
sir, then we have another question from this is Prantap from Navyuk Public School. So, the question is, how does the redistribution of solar radiation during the equinox influence atmospheric dynamics and global circulation patterns?
So actually, just the day of equinox doesn't make anything special for the atmosphere or for the atmospheric dynamics. The overall, the movement of the Earth around the Sun, and because of the inclination, and when the Sun is overhead for some certain places, overall uh, things do affect. And because of this, we know that uh, there are seasons and other aspects are there because of this. So one more important thing about uh, atmosphere is that if we don't have the atmosphere, we will have temperatures like there are on the moon. The moon, if the sun is shining on the moon, the temperature is very high, almost 100 degree, 150 degrees centigrade. But as soon as you go behind a shadow of a boulder or nighttime for the moon, you can say the other side of the moon, the temperatures are freezing temperatures, minus 50 degrees and even less. If this is what would have happened on Earth, life would not have been possible. So because of the atmosphere, what happens is the heat that comes from the sun is there even during the night. So we have a uniform sort of temperature. And you must have read about greenhouse effect. So there are certain gases which do not let the sunlight energy going out from the earth, and that will heat up the earth more. So there is a critical limit to the amount of greenhouse effect that we should have, because if we don't have greenhouse effect, life would not have been possible. So we do need greenhouse effect, but too much of this will heat up the atmosphere much more, and then our glaciers will start melting, and there will be other phenomena which weather-related phenomena which will be not good for sustaining life.
Okay, thank you so much, sir. That was again truly fascinating since how you are deeply and
Yeah, yeah,
thoroughly
yeah.
answering all the questions. So, okay, so given your work in both astrophysics and atmospheric physics, so how do you interpret the equinox as a point of convergence between the space science and Earth system science?
Right. So I think I did that convergence. So there is astrophysics and there is planetary science.
Hmm.
So although they are related, but how the solar system formed, this is a concept of astrophysics. But when we come to the weather related problems, or when we come to the actual orbit, or if the day of equinox and the day of solstice, then we say it is more of geography. So uh, there is a connection, one leads to the other. And there is another thing in space science, if you mean what our space organization is doing, we are having satellites making observations of Earth. So these are called remote sensing satellites. They are continuously making observations. So these make our understanding more and more precise about
Sir, sir, I,
time
I sir,
and exact meter or yes,
Sir, I think your
internet
voice,
is, I think.
voice is breaking. So what you can do is you can stop sharing your screen so that your voice quality is better. So you can, sir, stop the screen
Yes.
sharing. It will be better for
Yeah,
your
yeah.
voice. Yes. Now you can continue.
Yes. Yes.
So,
Yeah, I
sir,
think I was talking about um,
continue,
yes.
please.
Yeah, space science observations help us to make these predictions more accurate, uh, to exactly at what time the transitions will occur from one hemisphere to the other, and other phenomena. So these are somewhat related. Yes, I think
Uh, yes, sir.
uh, I have conveyed what was the question.
Yes, sir. You have already, but there I am seeing a lot of questions in the comment section, and one major question is that if Earth had no axial tilt, right, and how would the concept of equinox will it change or will it remain the same, or would we still experience seasons if there was no axial tilt?
So yes, that is a very interesting question. I just mentioned in the beginning of my lecture. There's life is possible because of this tilt.
Yes.
If there was no tilt, number one, there would be no change in season. All the time, equator will be hot, and rest of the places will be cooler, and there will be no change in weather pattern. There will be no change in the temperatures. So these are essential for various life forms to come up at different times of the year, and there would have been very limited life forms for that period. I'm not really sure what kind of life would have been there, but of course, the way we see it for us would not have been possible, probably. So, tilt is important. The amount of
Hmm.
tilt you can always discuss. If it was 15 degrees, what would have happened? If it was 40 degrees more than what it is today, what would have happened? So these are certain things which you can think of, and you can take it up as a homework and try to visualize. If it is 15 degrees, there will be tropical region will be smaller, and the regions which are cooler will be more in the on the earth, and how that will affect uh, rest of the things you can try to visualize. And if the tilt is 40 degrees, then you can try to think. So it's just a sort of imagination. It will be good for you as an exercise to start imagining.
Okay, sir. Then we have one question as so, how can ground based and space based observation complement each other in studying equinox related phenomena?
Uh, I think space-based. See, one thing is there that uh, this phenomena is for Earth, for any observation point on Earth. If you go to space, you will have a different inclination and a different position of the sun for us. But we make observations of Earth from space, and that does help in our making some predictions more accurate and trying to study the overall effect of uh, effect in the regions where sun is overhead. So otherwise, both observations are equivalent.
All
From
right,
space,
sir.
we can make a wider observation. From ground, we are limited.
Okay. Um, sir, another question is um, so, how do equinox event contribute to our understanding of global climate systems and long term environmental change? Am I audible, sir? Sir, am I audible? I think Sir is having a little bit of network issue. Meanwhile, I am getting a lot of questions in the comment section. What you can do is you can put your questions in the comment section sheet, which is pinned in the comments as well. And then I will take up the questions with the sir once his network is back again. So he's rejoining here and we'll be back with the Q&A section. Meanwhile, you can put your questions in the comment section here and as well as in the sheet. It is pinned in the comment section. Sir, am I audible? You are on mute, sir.
Yes, I'm sorry, my signal, my
It's all
internet
right, sir.
connection was disrupted.
Do you want me to repeat the question?
Yes,
Yes, sir. So, how do equinox events contribute to our understanding of global
global
climate systems
yes.
and
Okay.
long term environmental changes?
Yes. So it is not just the equinox phenomena, because this is, as you can understand from what we have discussed right now, it is just a one phase uh, of the motion of the Earth around the Sun. Uh, it is not actually the only thing contributing towards the weather. But whenever there is uh, sun and its interaction with the atmosphere, there is heating up of the atmosphere, which makes some circulation of air, and that in turn something which is there on the earth in that geographical location that will have certain effect on the air surrounding it, and these things combined together form a pattern, and slowly uh, the global effect is much more complex, and all this happens. But I would just like to add that it is not just the equinox phenomena which is affecting the global climate. It is the overall tilt and the uh, sun and the earth going around the sun, which is making the effect in the weather system, and also the circulation of atmospheric air around the sun, around the, because of earth is also rotating about its own axis, there are other forces involved here, so it is a very complex motion for a uh, gas like air in the atmosphere.
Okay. Sir, instead of all these questions, we are having a lot of questions related to the solar system and the planets. So, since you explained the solar system in your one of your slide, so this question comes up from Anshika Kumari from Amity International School, Mayur Vihar. Now, her question is: does the planets like Mercury and Venus play a role in March equinox as they lie in between the Earth and the Sun, affecting their relationship? Also, how
So,
does the science justify the rotation of Earth as a key factor in March equinox? So I think the last question you have already answered, but the first part of the question is
yeah,
a lot
the
there in
interesting
comments.
part is
Yes.
that uh, Mercury and Venus are closer to the sun. This they are in their orbits have a smaller radius, but which one is closer to us depends on our location with respect in our orbit with respect to their location in their orbit. So sometimes it may happen uh, when we are along the same line of sight with the sun, then we are aligned, and this uh, happens sometimes. This is some phenomena is rare, but it happens. And during this period, what we observe is a transit, because Sun is much bigger than Venus or Mercury. If Venus comes in between Earth and Sun, then we say it is a transit of Venus across the Sun. So Venus moves. We can see Venus as a dot moving across the Sun. This does happen, but it's a rare phenomena, and this happens only when the three of us, Earth, Venus, and Sun, are in the same line. And because the orbital periods of Venus and Earth are different, uh, this combination happens very rarely. So, same thing with Mercury. Mercury is also sometimes can transit for us. It can come in between the sun and us. There is a transit, but these phenomena do not affect our weather system because Mercury and Venus are very far off to have any effect on the atmosphere of Earth. So it is primarily the sun which is affecting.
Sir, there is a few questions related to daily life and some, like I'll combine the question. It is one of the same kind of a question. So the first question is, what are some of the cultural and historical traditions that people around the world have associated with the March equinox? This is from Anya Jain from Amity International School, Mayur Vihar. From the same school, we have Singhal, and her question is also the same kind of a question. Ki, does it have any effect on human behavior, daily life, or sleep cycle, or anything which happens on our day-to-day life with the equinox?
Yeah, not just the equinox, but the overall phenomena. Sometimes it does affect us. Like uh, for us in India, we have different cultural festivals related to our agriculture. अभी हो जा रहा है 10-15 मिनट. Sorry for the interruption. Like we have Makar Sankranti during the solstice, after the solstice, and we are having New Year starting. Indian New Year is starting with Ram Navami, beginning of Navratra during Ram Navami. So these are certain things which we do celebrate because, and probably they are related to our observations.
Okay.
So, but our sleep cycle is affected by the amount of light that is there. So, during winter, there is less sunlight for us. But in modern times, we are not dependent only on sunlight. We are dependent on our alarm clock, and uh, we are mostly are using artificial light uh, inside our houses. So that doesn't much affect our sleep cycle. But yes,
Okay.
there are hormones which help you sleep well.
Hmm.
So it's good to take 8 hours sleep every day.
Yes, of course, sir. So, sir, lastly, I have two questions at the end. Those are like looking reflections, forward-looking reflection questions. So, first question is, what are some emerging research areas where the study of solar terrestrial interactions, such as equinox, hold future significance? Like, if they want to build a career in it related to
Right.
equinox or maybe Earth and everything, so do they have any kind of area where they have to go?
Yes. So most importantly, you have to study physics, mathematics also, but a lot of physics is involved. And to understand the solar terrestrial means Earth relationship, you have to understand the sun because many changes are occurring on the sun also, and there are certain events that happen on the sun which affect us. Like there may be mass ejection. There are it's only ions because of the high temperature on the sun. There are only ions, and when ions move, there is magnetic field. And because of those magnetic field, there are very complex phenomena which are happening on the sun. So interestingly, India has entered in a very good phase of science related to the sun in the study. In this connection, India has sent its own satellite. You must have heard about Aditya L1, which
Yes, sir.
is L1 is a point in the orbit uh, in between the sun and the earth. Uh, Briefly, you can understand it is a point at which the gravitational force of attraction from the sun and from the earth are almost equal. So it is a very stable point, and we have a satellite there, Aditya, which is making observations continuously of the surface of the sun. It is studying how different uh, phenomena like circulation of atmosphere and change in magnetic field, and there is mass ejection. Mass ejection will be mostly ions and electrons, and how they affect come to the earth, because once something is ejected with a very high velocity from the sun, it will reach the earth, and because these are charged particles, they do affect the our transmission lines, our power grids, etc. So sometimes this study is important to predict certain event is going to happen. So in order to understand sun, study sun, you have to study electromagnetic theory, you have to study mechanics, you have to study thermal physics. So a large, mainly you have to study physics and uh, mathematics.
Okay, thank you, sir. So, moving on to our last question of the day. So, we have one reflecting question. So, what message would you like to share with our young learners aspiring to pursue careers in astrophysics and atmospheric sciences, or maybe a general key takeaway for them?
Yes, uh, it is very important that our students get interested in science and STEM areas, as it is called, science, technology, mathematics, and uh, uh, these aspects. But I would again add that in science, India is at a very uh, special position. We are going to have large astronomy facilities. We are going to have a gravitational wave detector, which uh, which is a very new thing. Only in 2015, the first gravitational wave was detected, and India is entering into this field. It was part of that international research, and we are going to have an instrument here in India. And in the budget this year, astronomy and astrophysics has been especially mentioned by our finance minister as it should be enhanced skills related to this field. So all these uh, imply that there are going to be a lot of funding and employment opportunities, and studying science is just for your curiosity, but if it is giving you uh, job and giving you life support, it becomes more interesting and you can relax and study science. So I would urge all my young friends to uh, be more involved in different aspects of study. And of course, uh, all the things cannot be done experimentally. So you do have to study books, you do have to do some theoretical study, and of course experiments and some observational uh, phenomena like the equinox and solstice and eclipse. These will uh, help you in your understanding, will encourage you, but you do have to study some theoretical things as well, because that is very much important.
Of
So
course,
I
sir.
encourage you everyone to take science and move
Thank
forward
you
in their
so.
life.
Thank you, sir. Thank you so much.
Thank you.
So, if you want to share anything else, you can. Otherwise, we'll take the closing of the webinar.
Yes, I would like to thank you for giving me this opportunity to interact with the students. Although I'm not able to see them, but I'm sure with your so many questions, I'm sure they must have taken up something. Thank you very much.
Sir,
Thank you.
I think you'll not believe if you'll go back after the webinar and you'll open the YouTube link, you can see the comments in the comment section. They are like bombarding the comment sections with the question. So I can see them. I can see those right here in front of me. So they have lots and lots of questions. But you summed up all the questions in such a manner that I think
So,
they have got their answers.
okay, I will go through that, and if there is something very typical or interesting and I need to answer, I can connect through you and you can put it up on the
Sure, sir.
YouTube.
Sure. So,
Thank
thank you, sir, and thank you, everyone. So, I'll just take up the closing here. So, as we move towards the conclusion of today's session, let us briefly reflect on a few takeaways. That today we learned how the March equinox represents a moment of cosmic balance, when the Earth's position in its orbit result in nearly equal day and night across the planet. Then we also explored how Earth's axial tilt and orbital motion play a crucial role in shaping the seasons and influencing natural cycles on our planet. And With that, sir also told us few things from his background related to space, earth, and planetary sciences. And astronomy reminded us that even the movement of our own planet is part of much larger cosmic story. So, which encouraged us to observe, question, and explore the universe around us. So, on behalf of Space India, I would like to extend our heartfelt gratitude to Professor Shantanu Rastogi for sharing his valuable insight and interacting with our students today. I would also like to thank all the participant schools, educators, and students for joining us and making this session engaging and interactive. So, we hope today's discussion inspires many of you to continue exploring this fascinating world of astronomy and space science. And thank you so much once again for being a part of today's session. And have a wonderful evening and keep looking up at the sky. Thank you so much, sir. We had an amazing session with you.
Thank you very much. It was my pleasure. Thank you.
All right.